Okay, in this video, we're going to look at the equation of a straight line. But before we go into the theoretical consideration, we're going to go on to an XY grid and work through some practical examples to try and show you how equations of straight lines come about, and hence sort of put across the significance of what equations of straight lines actually mean. Right, so let's go to the grid here. So here we have got an XY grid. We already have some straight lines there, but before we go into these colored straight lines, let's make some straight lines of our own. I'm going to start with a vertical straight line. So suppose we have this straight line down through here. Okay, we're going to put on some of the coordinates of this straight line. So for instance, we have here it's going to be 4 2 4 2. This one here is going to be 4 minus 1. This one here is going to be 4 minus 3. And let's do this last one here, 4 minus 4, or perhaps this one, 4 4. Okay, now the question we ask ourselves is what do all these points have in common on this straight line? And the answer is going to be the fact that all of them has an x-coordinate 4. Okay, so all of them has got an x-coordinate. There's 4 here, 4 there, 4 there, 4 there. And so because all of them has got an x-coordinate 4, this straight line here, we give it the label x is equal to 4, and so that becomes its equation, because all the points on this vertical straight line have got an x-coordinate of 4. Right, so that's that. Let's take another example. So let's remove all this. So in fact, you're going to find that if we take any other vertical straight line, suppose we have this one here. So all we need to do, if it's vertical, is just find one point and its coordinate. This one is going to be minus 2 1. And so since the x-coordinate is minus 2, this line is called x equal to minus 2. So as a general rule, all vertical straight lines are labeled x equal to some number, where that number is the x-coordinate along that vertical line. Okay, so that's the conclusion for that. So vertical lines are called x equal to some number, where that number is going to be the x coordinate. So this line, for instance, is x equals to 2. This line is x equals to minus 5. This line is x equal to 3. This line, which is the y-axis, is x equal to 0. All right. We're going to now look at some horizontal lines. So let's take this horizontal line here, for instance. I'm going to just take maybe 2 points. This point here is 2 minus 2. This one here is minus 2 minus 2. This one here is 5 minus 2. You can see that in this case all the points have a common y coordinate minus 2. So that straight line is called y equal to minus 2. Then similarly, this horizontal straight line here would be called y equal to 1, because all the points are going to have a y coordinate of 1. Okay, so from this one we can state and conclude that all horizontal lines are called y equal to some number. So horizontal lines are called y equal to some number. All right, so that's it with horizontal and vertical lines. We're now going to start looking at these lines that come at an angle. These lines are called oblique. Okay, we're going to start with the red line here. So this one. So let's label some coordinates. So this one is minus 1, minus 2. This one is 1, 2. This one is minus 2, minus 4. This one is 2, 4. And then we're just going to do a quick comparison of the x and the y coordinate. So perhaps what I'm going to do is I'm just going to form a table this side. X coordinate, y coordinate. So when x is 2, y is 4. When x is 1, y is 2. When x is minus 1, y is minus 2. So then you I think going to notice that this y coordinate is always 2 times the x coordinate. So the question is, how do you get the y coordinate from the x coordinate? So that is the basic question behind what we're going to call an equation of a straight line. And in this case, it's a simple rule. If you take the x coordinate and multiply it by 2, you get the y coordinate. In words, y is always 2 times the x coordinate. Okay, so along this line here, y is always twice the value of x. So here y is 2, x is 1. Here y is 4, x is 2. Here y is negative 2, x is negative 1. So if y is always twice the x coordinate, so what we write is y is equal to 2x, then that becomes the equation of this red line. If you like, it is its identity. All points along this line must satisfy this condition that if you take the x coordinate and multiply it by 2, then you get the y coordinate. All right, so what we're going to do is we're going to write y is equal to 2 along this straight line here. So that is its equation. We're now going to go to these other two lines and try to see if we can establish their equations. Okay, so let's start with the blue line. For the blue line, the coordinates for this one, 3, 1, for this one, 2, 2, for this one, 1, 3, this one, 0, 4, this one, 5 minus 1. Again, I'm going to put them in tabular form this side. So when x is 0, y is 4, x is 1, y is 3, x is 2, y is 2, x is 3, y is 1, x is 5, y is negative 1. So 3, 1, 5, negative 1. So again, the question is, how do you get the y from the x? However, sometimes it's a matter of can we find any pattern, and here for this particular line, notice what happens when we add x to y. Okay, for this one, 0 plus 4 is 4, 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1 is 4, 5 minus 1 is 4. So it looks like the thing that's happening for this blue line is that x plus y is always equal to 4. And so that is going to be its equation. Okay, so if we just take away all these workings, then we're going to put x plus y equals to 4. That is the equation of the blue line. And then we're going to go to the green line. And then after that, we're going to go back to the theory. So this one, we are saying x plus y is equal to 4 is the identity of that blue line. Let's take some coordinates of the green line. So right here we have minus 6, minus 2. Here got minus 4, minus 1. Going to jump here. We've got 0, 1. here we have got 2, 2, and there we have got 4, 3, right? Again, I'm going to tabulate them here so that we can start looking for some, if we can start to look through to see whether there are any patterns. So start with 0, 1, 2, 2, 4, 3, negative 1, sorry, negative 4, negative 1, negative 4, negative 1. Just looking at these, you might want to notice that these ones are going up in ones, while these ones are going up in twos. Okay. So, so maybe a starting point would be to take the y's and multiply them by 2. So let's see what happens when we do that. So take the y's, multiply them by 2. If we do that, so 2y, then 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times negative 1 is negative 2. And then now you can see that all of a sudden these are also going up in twos, which is the same as what's happening there, which perhaps is a bit promising. But still, these numbers here are not the same as these numbers here. Notice this, so I'm going from y to x, just because the opportunity made it a bit easier. But if you compare these numbers to these numbers, you've got 2 and 0, 4 and 2, 6 and 4. You can see that now from this one to this one, if we subtract 2 from these numbers, we get these numbers here. Okay? Because 2 minus 2 is 0. 4 minus 2 is 2. 6 minus 2 is 4. Minus 2 minus 2 is minus 4. So if we do 2y minus 2, so let's just do that and see what happens. So 2y minus 2. Then what we're going to get now here, subtract 2, we get 0, which is the same as this one. Subtract 2 here, we get 2, which is the same as this one. Subtract 2 here, we get 4, which is the same as this one. So what this thing is telling us is that 2y minus 2 is equal to 0, is equal to x for this green line here. And so 2y minus 2 is equals to x becomes its equation. So the equation of a straight line tells us, gives us a rule of getting y from each x or x from each y. Okay? And while for these three lines, the way we have found these equations had a lot of some trial and error, okay? But the point of this section was to show you the meaning of something like 2y minus 2 is equals to x. What does it mean? X plus y is equals to 4. What does it mean? Where does it, come from? Or indeed, y is equals to 2x. Okay, so with that in mind, we are then going to show you a systematic way of finding these equations, which eliminates the trial and error that we're doing in this little experiment that we did here. Right, so if we go back to this other page, so let's establish the theory then. Okay, we're going to give you 3 forms of the equation of a straight line. The first form is what is called the standard form of the equation of a straight line. Okay, and it goes like this. So the standard form of the equation of a straight line is, let's say it's given by y is equals to mx plus c. Y is equals to mx plus c. Now, in the previous section, one of the equations was y equals to 2x, which you are going to recognize is a bit in this form. Now, the equation y equals to mx is equals to mx plus c applies to a straight line which has got a gradient of m and goes through the point 0c. So this line has got gradient m. So let's finish this sentence here. So the sentence finishes where m is the gradient and c, we have explained what the gradient is in the previous video on straight line segments, if you'd like to check that one. And c is the y-intercept. So basically the y-intercept is the point where the straight line crosses the y-axis. So that's why it's called the y-intercept. So this is the x-axis and this is the y-axis. Okay, so this is the standard form of the equation of a straight line. Then there is what is called the 1-point form. So this time, suppose we have a straight line. Suppose we have a straight line that passes through so we know one point that it goes through, and let's call that point x1, y1, with gradient m again, so like in the previous case. So graphically this is what is happening. So there is our straight line. Still it's got gradient m, but this time the point that we know that it goes through is not necessarily this one. Maybe it's some other point there. So that point could be there or somewhere here, and that point is given by x1, y1. So that's the y-axis, that's the x-axis. So the 1-point form says the equation of this straight line. So suppose I have got this point. So its equation is given by, it's going to be y minus y1, y minus y1 equal to m times x minus x1. Let's call this equation 1. This one is going to be equation 2. This equation is called the 1-point form. So this is the 1-point form of the equation of a straight line. Okay. Then the final form that we are going to introduce to you is what is called the general form of the equation of a straight line. Then in the next video we're going to start looking at examples of how these theoretical considerations apply when we have to find the equation of a line. So the general form of the equation of a straight line is given by ax plus by plus c equal to 0. So in different setups, we are going to either be given or be required to express our equation either in the general form, in the 1-point form, or in the standard form. All right, so hopefully that sets up and that explains the thinking behind the equation of a straight line. So in the next video we're going to look through some examples where we use these formulas to find equations of straight lines, and hopefully this video has been well enlightening to you, and thank you for watching. You please do subscribe so that you can get notified whenever we post new stuff on these sort of topics. Thank you.